Welcome again to Wickerson Studios. This is my 50th script of 1001, and I am running over all of the nodes. And in this one, it's a hot day out here in Kansas City, Kansas, between Canada Day and America Day, or Independence Day. How I usually set up these scripts is I'll bring in the nodes I plan on having a look at. What I chose was to go into the maths. We'll turn off the turntable for now. Not finish up with the maths, so go a little deeper into the trig, which ends on some really cool, certainly applies degrees to radians to degrees. I like working in radians, it makes sense to me. And right angle trigonometry and triangle trigonometry we're going to do. So you jump over with this little key and see what's happening. If you have a right angle triangle, you really only need one angle on a couple of sides, and you can get all the data from all the other things that are being inputted. There's no point having the gamma set up here because we know it's 90 degrees from that small symbol. The next one, which is really nice, you can just provide, and like I said, I like working in radians. So if I set that to a 90-degree angle there, it's going to behave exactly like the script up here. But you'll get out all the data that you need. Then I'm going to apply it to a script. What I did was I built this object. So let's jump out of here and just have a look at it for now. It's kind of a cool thing. It's definitely uses some interesting maths, and I'm going to show you how I built it. In my mind, I went in and I decided to build an ellipse, which I usually don't begin with. And I divided it into points, 3 points, and I took an explode tree, saying, because I'm going to explode the tree just to these 3 paths, I'm probably going to internalize the count, so it can't be changed unless I purposely drag it out, because I don't want other people doing it. I can change the radius and do things like that, which is kind of fun, and that will affect my geometry completely, and it will go pretty slow right now, so I'm not gonna do that. I took my paths out and actually found nicely the centroid, the circumcenter, and if you take a look down here, the incenter and the orthocenter. I thought those would be fun to play with those, and I basically pulled out the points and all 3 lines. I chose them. I didn't end up using the lines for anything, but I leave them there. I moved the points up in each case, and I'm just going to take off my group so I can grab these quickly. You can see all the points being moved up here. In that sense, I drew a line for those to those other 3 points. And you get used to using flattening and graphing, and you get a little more into using lists and data trees. And even though my script is pretty chunky here, I wanted to visualize it so I didn't have to make notes. I do that quite often. So I built this series of kind of triangle pyramids that go to those 3 lofted points. Actually, should be 4 lofted points, and there they are. And then I loft between them, but I'm not closing off those lofts. I'm leaving them open. So I actually have these really nice, subtle, beautiful forms. And to me, they're just defined by a loft around an ellipse that can change. I take all of them, and I realize at that point, okay, I want to take them along with the points. And I might make this a little bigger so you can see it. There's the points on the ground. There's the lofts in the air. And what I did was I put them through a rotation. So in grafting them, or in flattening, I should say, I can have control over those going from all the way over to 2 pi. So I set that at whatever angle I want. Then I do the same range and z-component loft on them because I wanted them up in the air, all pivoting in different ways, and I drew a surface out of them. Now I wanted to do an extrude surface, and the extrude surface is an interesting thing. I draw points on them, but not too many. And I deconstruct the brep so I can grab the vertices. And I grab one vertices that I've flattened and pulled out of all the lists. I could graft it to get different geometries, but in doing so, with all of those points, that list item goes off to the top part. The points of the 4 or of the other ones come off on all the angles to be interpolated into a strange little curve that I've decided over here to pipe with a graph mapper and a range, so I can have some control over what joins those things together. In other words, I took the points. I have a vector display that shows where it wants to extrude, and in extruding I flipped the negative and just did a simple extrusion in that direction. And I had multiple things that came about. And because multiple objects came about, you can see a list here of 32 objects. That would be 8 on each of them, extruding in different directions as separate separate points. I then did a rotation on each one and ended up with this interesting form, which gives me 32 closed breps. Which I then can bring into my pipe. And in the end, I'm left with this fairly interesting piece of geometry that if I slowed down and made it, I don't know what kind of crazy lamp that would be. I enjoy it. I like making stuff like this. I like it being parametric. And let's just do a quick change from the very, very beginning and take our ellipse right here and take our data in the ellipse and make it very long. And what I'm going to do is turn my solver off, move this up to, that's a little too big, let's double it, and hit solve raw and see what happens. And there's a beautiful shape. So you've got a very interesting piece of geometry that you could make yourself. It does rely on symmetry. It does deal with rotations. You do get into that. It just provides something in the round that people like to enjoy and like to see. Anyway, hope you enjoyed it. 5-minute video, rotated lamp, let's call it, and we'll just throw it back into turntable to end with it kind of spinning around. And you can do all the colors and everything you wanted to do, but there's a bunch of clothes preps that you probably or maybe wouldn't make in Rhino, but you will make in Grasshopper, and you can make it in a large variety of ways, let's say, or many, many. All right, thanks very much for watching.